today we're going to talk about the 5.1 vectors section B. Okay, 5.1. Like this. Okay, we already talked about it. A is a scalar and vectors. Now we're going to talk about B. B is vectors, presentation, and notations. Okay, so today we're going to talk about vector representation and the notations. Okay, so we know from previous section we know vectors, has two atoms. One, we have the magnitude, and then vectors also have the direction, right? Okay, so how to represent vectors? So basically we use a director. So to represent vectors we use a director line segment. Okay, so how to represent this? Let's draw a line. For example, we have a line here, this direction from P to Q. Okay, so they have a direction here, and then they have a length, but we use A. Okay, so there's another line here. So we can represent as from S and R. Okay, so the direction is this. This way is the direction. We use it as a B. So basically it's a point. These are all points. They're all points. Okay. We have these two lines. Okay. So this here, from here we have one for this direction line. So basically there's two items we are looking at. So the direction. So first item, direction. We use the arrow and arrow. Okay, second thing, so the magnitude. Magnitude. Then what we use is the length of this line. It's the length of this line to represent the magnitude. So basically we have two segments. Direction, use the arrow. Magnitude, use the length. Use the length to represent. Okay. So the diagram shows here also. Okay, that's the initial point P, and then this is the terminal point Q, and then they also have a initial point R, and this terminal point S. So basically, so how from here, so we have these two diagrams. How to represent these two diagrams? So from here, now we see how to represent, how to notification of these things. Okay, so we have also notation. How to notation this things. So basically, for directions, you can draw in this way. So from P to Q, we draw arrow on top, or sometimes we just say A. Okay. The next one is the magnitude. So then we write in this way. We write in this way to represent this vector, or sometimes we write in this way. Similarly, for this R to S, we also can be write in this way. We write RS, or we write B. Of course, there's a direction on top. And then the second one is magnitude. So we write in this way. So this is S. We write it this way. The B. Then we draw 2 lines here. Alright. Here comes a remark. Here comes a remark. So basically, the vector PQ and the vector QP from here to here. So these two atoms, they are different. They're different because PQ is the initial point is P and the termination point is Q. So from P to Q, it's moving in this direction. And then QP is this the starting point, this ending point. So they are moving in this direction. So these two having different directions, so they are different. So let's look at this. And then in fact, they are not only different, they are actually in the opposite direction. Okay. Just take one is from here, the other is from here. Okay. Okay, good. Alright. Continue. So the next concept we will talk about is how to represent the vectors in the Cartesian plane in the diagrams. Okay. So how to represent and vector in the Cartesian plane. So okay. So can we represent the vector in the Cartesian plane? Okay, so this thing we're gonna do. Alright, we can use another example. We can use another example. Cartesian plane here. Okay, assume this is y-axis, and then this is x-axis. Okay, right? Okay, and then we have 1 angles. So from here, so we have 1, 2, 3, 4, 5, 6. And here the same thing here. 1, 2, 3, 4, 5, 6. Okay, so we have the point 4. This is 1, 2, 3, 5, 6, right? Okay, and then we also have another one. It's 1, 2, 3, 4, 5, 6. Okay, let's do one. Let's draw one line from here. And here, now it's going to draw one line from here. Okay. Assume this is A and this is B. So we have a line is going up in this direction. So this is A, and this is B. Okay. And then we also have another line. So at the line D, D is at this D. And then we also have another line for here. We'll draw another line, so they're coming down. They're coming down. They're coming down in this direction. So this is C, this is D. They're coming down. Okay. So the vector A to B. Okay, these vectors can describe displacement of three units to right. Okay, how to know this is 3 units to right? Okay, let's look at this thing. Because the original coordinate from A, that is 1 to 1, and B is the 4, 1. Right? So from here we can see it's like we have 1, 2, 3 unit, and then in the y-axis they have how many? 1, 2, 3, 4, right? So from here, y minus 1, so you have 1, 2, 3, 4. So 4. Okay, so in this case, we can see that this place and of 4 unit to going up, right? Going up. This is to right, this is going up. Upward. Right? So this is the thing. So for this, so basically this vector A to D, so they're moving 3 units to the right and 4 units upwards, so they reach here. So this is the direction, right? Okay, another one. Let's look at C and CD. So it is the same thing. Displacement of, let's draw a line. So assume this is 6 to 4 for the 6 to 4 for the C, and then 5 to 1 in the, this is we call it rotation plan, right? Okay, so let's draw this line. Okay, so if we look at in this view, so 6. Okay, this point is 2. From this point to here is 6. Then moving this direction 1 unit. And then this, for this direction, this is how much? This magnitude is how much? This magnitude is 4 minus 1. So it's 3, right? If you look at here, 1, 2, 3. So here magnitude is how much? Is 1, right? Okay. Displacement. So in this case, as of from C to D, so they're moving 1 unit to the left, 1 unit to the left, right? Okay, and then the other one is what? So they're going down, right? Going down, right? So this magnitude in this direction is 1 unit. So in this direction, in axis is 3 units. So it's 3 units. 3 units downwards. Right? Unit 3 units downward. So therefore, here comes a very important information. So the answer is, so we can represent them in this way. So we can write them using a column vector notation. Column notation. The stamps we can write in this way. A, B, in this way. So we can represent in 3 units to the right, 4 units to the up. 3 to the right, 4 units up. So we can write this. Okay? And say it's going down, right? So 1 displacement and 3 displacement. So we write in this way. Just take note. So because this is going this direction. So from assume this is one of the origin. So from here, so when we move in this direction, it's minus 1. Okay. When you going down, 3, going down 3, so it should be minus 3. Okay, we'll copy this. So So the answer is CD is going to this way, right? This way and downwards. O is minus 1, minus 3, right? Okay. So now we move to another one. So how? Now we know the direction. So what is that? What is the direction? You're moving this way, moving this way. Okay, they're moving this way, they're moving this way. We know the direction, so we have to find out magnitude. The answer. Just now we say what is the magnitude for this one? So this signal, right? Remember we did this one. So in the sense it's like this. So 3 and 4. So is the answer? The answer. 9 plus 16, so it's 25. Then we get 5 units. Right. Let's see how to C to D. In this direction, moving downwards. This is 1 plus 9. 10 units. Okay. So this is very clear. So in this case, we can say that, okay, in all this Cartesian plane, we can use the vector, the column vector to represent A to B and C to D, right? So this is, okay, this is to summarize. A to B, we can write B, 3 left, up, to the right, to the up. And then CD is going down, so go down 3 and go to the right, go to the left, 1. Go to the left 1 means -1, go to down means -3. Okay, so but always remember, so in this magnitudes, so we call this as the X component. And this is a Y component. Okay, so let's always write X component on top and Y component in below. Okay, so this is rather very clear. So let us remove this thing. Okay. Okay, maybe probably we can summarize here. Yeah. So in the Cartesian plane, so we can write a column vector such as X and Y, right? We call it column vector. Represent X column, X unit and Y unit. So just remember that X is the X component and the Y is the Y component. So always on top. This thing have always on top. This one always on right on the bottom. Okay, gonna be the other way. Must be always like this. So 3, 4, right? Okay, gonna be opposite. Yeah. And the magnitude. So now we have these things. So we have to say the magnitude. Right. Column vector of this we will write this way, just now we have to calculate, right? Okay. Okay everyone, thanks a lot for watching. So today we'll talk about this basically we'll talk about 5.1 chapter 5.1 introduction to vectors. So P, vectors representation multiplication. So we talk about vectors, there are two items, magnitude and the direction. So then we use how do you represent the vectors in the Cartesian plan. How to represent. So if I see we have a line here, so this, if you have a line here or a line here, so how to represent them in the Cartesian plan. So basically we can write a column vectors x and y. Okay, x is the x component. X component must be on top, y component must be below. So always remember this tree. This means okay, the point A to B. Okay, A is the starting point, B is the ending point. So to move to here, so basically they move 3 units to the right and 4 units up. So this is the way how to write. And then for this line is going this way to D. Okay, basically they just move 3 units down, 1 unit to the left. So in this case, whenever we moving to the left, so we have to put a negative. Okay, so going down also another one. So similar as what we write here. Okay, and then when we calculate the magnitudes of the column vectors, let's say for example we have x and y. So moving to the right 3 unit. 4 unit up. So how we calculate this line? Right? Let me use this. Right? We have this thing. Okay, that's all. Thanks for watching. Bye bye.